Great, thanks, Shizuka. So first, we'll start by talking a little bit about what wolfSSL does and the fields that wolfSSL plays in. So as you can see here, we have everything needs from customers in everything from um, automotive to aviation to network appliances. Pretty much you name it, anywhere there's secrets that need to be kept and servers and peer and clients communicating, we can help out with securing that communication data. Next slide. So wolfSSL likes to think of these in kind of three different areas. So data at rest, this can be things like a database that might be need encryption. Data in transit, this is what most people are familiar with. So up here, a client and a server, two peers that need to get to talk to each other. That can be secured with TLS or SSH. And wolfSSL is very flexible in that we can take advantage of any transfer medium that might exist underneath. So things like TCP, Bluetooth, serial, we've even done a CAN bus. And then kind of a third box we like to stick things into everything else. So this be stuff like firmware updates where you need to encrypt and authenticate a firmware package. Yeah, so next slide. So the company itself has been around since about 2004. We're currently partners with about 2,500. We have about 2,500 customers. We've got about 17 resale partners, including OS vendors and chip manufacturers. And any given moment, we like to think we're securing around 5 billion connections. Next slide. Thanks. So this is wolfSSL's project lineup. So wolfSSL, of course, is the product that contains the TLS stack. It supports all the way up to TLS 1.3 and DTLS 1.3. We're actually one of the few libraries that supports DTLS 1.3 that came out a couple of years ago. It's finally ratified. wolfSSL consumes wolfcrypt. That's where all the ciphers and algorithms live. So we've taken wolfcrypt through certification. We've had our 140-2 cert for several years, and we finally got our 140-3 certificate last year. That was a big deal. We also do other industry-specific certifications, such as DO-178 DAL-A. That's an avionics safety critical certification. And then we've also got an MQTT client-side library. It supports all the way up to version 5.0 of that specification and the sensor network or SN specification. It, of course, uses wolfSSL for the TLS connection, wolfSSH for secure sockets. That's basically a client and server side. And I think in the last 2 years, we developed a daemon for the server. So basically you can run in the background. And it supports up to SSH 2.0. And then TPM is our trusted platform module library. And so anybody that's looked at the trusted platform module specification would know that it's fairly complex. This library basically allows you to easily access all the features of the TPM chips from your application. And Wolf Boot is our secure bootloader project. Uh, Pretty complex and if you think about it, but it really just boils down to doing takes advantage of the flash IO atomics. So just to read, write, and erase are the only necessary porting pieces. And then Wolfboot can also take advantage of any chip-specific boot management features that might exist. And it can also be part of a multi-stage bootloader process. Wolf Sentry is our embedded intrusion detection and prevention system. So it's fairly flexible. You can think of it kind of like an embedded firewall. So you can either allow or disallow connections that are coming in, and it also has hooks to allow you to do application-specific things. Like if, for instance, if you have a login attempt with the invalid password 3 times, the application can shoot off and do a special handling of that connection. Then Wolf HSM is our newest project. That's our hardware security module library. Basically allows you to take advantage of a physical HSM features in the same way that you would with a TPM, things like key storage and management. Um, we've also got the option to do a software version of an HSM in Fabric on a like a Xilinx board. And then we've also got Wolf Engine and Wolf Provider. Those are two libraries that allow you to use your existing OpenSSL library with a FIPS certified cryptography. So you could plug in Wolf Crypt FIPS into your existing OpenSSL implementation. And then all the OpenSSL applications that are on top of that can be certified with FIPS. The middle row there is wrapper layers. So we support everything from Java, C#, Python, JavaScript. Basically allow the most customers possible to use our wolfSSL and wolfcrypt libraries, no matter what application language they're using. And then the bottom row is kind of tertiary things. So everything from, I think the interesting one there is wolfclue. So wolfclue is our command line utility. It's analogous to like the OpenSSL S client utility. And it also does things like certificate creation and parsing, rudimentary encryption, decryption operations. And then wolfSSL also handles the curl project support and maintenance plans. So we're actually partners with Daniel Stenberg of the curl project. And so he actually wrote another version of curl for specifically for embedded systems called Tiny Curl. And so we also manage that. Next slide. So testing is huge at wolfSSL. It absorbs quite a bit of our time for good reason, right? So all these tests here that are listed, these are all things that are run whenever somebody submits a change request to this to our as a PR. And I think the interesting ones there are the fuzz testing. So basically, we use a lot of third-party fuzzing tools. And those have helped us out quite a bit and brought out some interesting corner case issues. Um, we've also done a lot of development with static analysis, or always adding new static analysis tools. And we also rely on our university and research partners to help us out. Next slide.
Okay, thanks,
You're
Eric.
up, Doug.
Yep.
Yeah, thank you.
Great introduction there, and just a quick minute on an introduction to embedded access in case you're not familiar with who we are and where we've come from. We are located in Ottawa, Canada, and this is actually our 21st year as a company, but our roots actually go much further back than that. Back to the first days of the MQX RTOS and all the associated libraries that we'll see some of later on in this webinar. Tons and tons of experience with doing pretty much anything you can imagine in the embedded software space. And we are actually a gold level partner of NXP Semiconductors and have extensive support for all of their MCUs and crossover processors, even some of their microprocessors. We have been doing, as I mentioned, pretty much everything in the embedded space, developing and licensing software products as well as services. So very, very high level on the products. We have the operating system, TCP/IP stack, various file systems such as FAT32 and exFAT. If you're using storage media that's greater than 32 gigabytes, you're going to need exFAT. As you know, it comes pre-formatted in that form factor. Various IoT protocols, and quite a bit more. On the services side, we do full application development for customers, develop secure bootloaders. We can port legacy applications, either porting them to MQX, or if we're using an older version of MQX on a legacy processor, we can help port that to a newer processor and latest version of MQX. And we've done things like protocols and custom driver development, that sort of thing. So a quick look at what MQX is, like all operating systems, there's at the core a scheduler and then a small set of core services. And this is actually the minimum amount that you need. Way back when it was first developed, footprint was hugely critical, and so it's very tiny to start with, but then it scales from there. So there's a large number of optional services, and pretty much any feature that you're going to find in a real-time operating system, you'll find in MQX. Extensive driver support. We'll see later on the I/O subsystem and I/O drivers here. There's also a full complement of low-level drivers, and so we can support pretty much any peripheral you're going to find on a modern processor. Ethernet Wi-Fi drivers going into the full TCP/IP stack. USB with host and device is one of our file systems. The shell is a command line interface. And then around all of this is the user application. And we draw it this way just to illustrate the fact that your application can access all of these components directly through the API. Now, I mentioned that MQX goes back a very long time, 35 years, but it doesn't mean that it's static and not maturing on a regular basis. And so on the right-hand side, we've got a very high-level summary of some of the more recently added features over the last several years. So that includes various IoT protocols. The TCP/IP stack is IPv6 compliant, JSON parser and CJSON parser framer, XML parser framer, some compression utilities. RP message here is excellent way to facilitate inter-core communication. So if you're using a multi-core processor, and MQX is running on both, you can use this communication link to synchronize tasks on one CPU with tasks on the other CPU, or even in an I.MX type of environment where you have a larger core that might be running Linux, you can use RP message for inter-core communication, which is a great way to keep the two sides of the house synchronized. Supports Lua scripting language. Continually modernizing it, supporting latest coding standards. Many of the MISRA rules are supported, constantly updating and porting to new processors as become available as well. And MQX was not written for any one particular market vertical, and we find that it's been used in pretty much any market that you'll find a microcontroller or a crossover processor being used these days. So extensive use in all these different sectors. This is just a small subset of the types of applications our licensees have been using MQX on: extensive industrial control, telecom, medical, consumer, transportation, and test and measurement. But regardless of what sector you're in, security is becoming paramount, and so it's a great time to have an introduction to the success of Wolf products and MQX. And to that point, this is a quick summary of how one customer has used both families of products. They're making essentially a SCADA device that is remotely monitoring and reporting on equipment and environmental factors up to a central reporting PC. And they had been using MQX for well over 10 years on an older version, but they wanted to upgrade that, and the requirements changed, like so many now, where the various connections were going to require some degree of security and encryption. And in order to do that, they leveraged a couple of products from Wolf, including wolfSSH to secure a TCP socket connection that is used for configuring the various alarm points and reporting that back. And they also leveraged wolfSSL to secure web pages that are being served up by their embedded device. And that's used by the user to see the status of the alarm points and configure their device. But it's also very helpful from configuration and testing and providing firmware updates. And at the end of the process, they told us that using the existing integration of Wolf and MQX products made their project very straightforward and much easier to implement than they were originally anticipating. So with that, I think we'd like to get into some of the details about various products from Wolf and how that integrates in with MQX. And I'll start with wolfSSL since that's their flagship product. And it has been used in many, many different ways with an MQX-based environment, but there's three different buckets or categories that are typically used. I mentioned just that previously the customer used it to secure various web pages coming from the web server. And so the user navigates then through HTTPS connections. And wolfSSL can also be used to secure a proprietary communication link that is socket-based. So you may have a proprietary connection between two embedded subsystems, or your product may be reporting up to a centralized server, for example, over a proprietary link. And that needs to be secured in order to prevent someone from sniffing on there, reverse engineering and stealing your data and that sort of thing. And the third of the more common use cases is to secure an upper layer protocol, such as MQTT or Telnet, SMTP, that sort of thing. When you license wolfSSL, what you get is a library in exactly the same way that all of the MQX components come as separate libraries. And it's provided with full C source code. And it is pre-integrated, of course, with MQX, but also pre-configured. And wolfSSL comes with many different options there, and we configure those to the most common settings. But of course, you can go in and tailor that to your specific requirements. And you can also set it up to prioritize the footprint or performance. And that just depends on your requirements and available memory and that sort of thing. RTCS is the name of the TCP/IP stack that's included with MQX. And that provides an SSL interface, which includes a shim layer. And that allows you to easily turn a non-secured normal socket into an SSL secured socket. And this is available to use to create a socket really just as easily as it is to create an unsecured socket. The advantage of having this SSL interface built into RTCS is that if by chance you started out years ago with a different solution or maybe an open source SSL and you're now ready to upgrade to wolfSSL to take advantage of the newer features in a more robust environment, it's very simple to do. You just swap out one package for the other and you're good to go. And I mentioned the level of integration. So really adding this in has very little on your end to do. The main thing that you need to sort out in advance is what your requirements are, so you know which way you're going once you get access to all of this, and you won't need to know how to configure and optimize it to suit your system level requirements. So a quick look at the API that you would use in this particular case. This is actually very similar to the API that we use for an unsecured socket, but as two things. You see that there says SSL right here in the API, and there are some parameter differences, but really, if you're moving from an unsecured to a secured environment, it's pretty straightforward. All the calls are the same. You just have to quickly go through your application and switch it over. From the unsecured version to this SSL version. And you can actually use this combination of products in more sophisticated environments. So for example, with the web server, you can instantiate multiple instances of the web server. And that allows you to do a variety of things, including mixing and matching which ports are secured and which ports are unsecured. And the easiest way to explain that is through a little diagram here. So at the bottom, of course, we've got the operating system and associated drivers. Above that is our TCS, a TCP/IP stack. And sitting above that is where you have the wolfSSL package. And then you're going to have multiple instances of the web server. I'm only showing two, but there really is no limit other than the practical limit of what the available resources such as memory will support. And those web servers are going to want to talk over the network, of course. And as I mentioned, then you can set up one instance of the web server to use port 443 to have a secured connection. And you can have the other web server set up for an unsecured environment. And it's easy enough to switch switches around. You can tear down a connection and then initialize it for the different configuration. Similar story if you're using MQTT, for example. So the bottom, of course, is going to be the same, the operating system, TCP/IP stack, and wolfSSL. But instead of a web server, you're going to put in multiple instances of the MQTT client. And those will want to talk over the network to your broker, when that could be a local broker or remote. And excuse me, similar to the web server, you can have one port that is secured, another port that is unsecured. And of course, if you want to change these around, you can do so on the fly. And that's a quick summary of wolfSSL, but we also have integration with wolfSSH. And in a similar way, there's a number of common use cases that it is used in. It's used in many different ways, but it boils down typically to three different types of connections. And the first two are similar, but it's worth explaining a little bit the difference there. SSH does come out of the Unix world, and it has two modes that you can operate it in. One is a single command, and the other is sending multiple commands while you retain the context. So in the first case, you're really just sending one packet, and that includes all the login information and the command that you want to send. So it's a very short-term connection, and you get in and out. It's not as commonly used as the second case, which is for multiple commands. You would issue from your PC a command, and then you get the result back, and it retains the connection. And so the advantage there is that you can see the history, or if you use the up arrow, for example, you can see previous commands on the console and that sort of thing. And that's typical from what you're used to in a command line interface. And the third use case is for Secure File Transfer Protocol, SFTP. And as the name implies, it's for securely sending files to and from your embedded device. In concept, it's very similar to File Transfer Protocol, FTP. But behind the scenes, it's actually far more, quite different, far more sophisticated, of course, because it has to do all of the security and handshaking and that sort of thing. So MQX also has an SSH server, which is built into the TCP/IP stack, and that manages connections coming in to the device. And it also manages the interface to the shell library. It's a standalone library called shell, and that's what provides the interface or command line interface. And you can easily add a secure command line interface to your application and customize it for things like password verification, access to logging information, updating settings, whatever you really want in there. And so you can exercise IO that you want, change operating parameters and modes and that sort of thing. And it's really quite easy to extend on the command set. So this is a screenshot of one of the arrays in an example that comes with MQX. This is a partial set of the commands available. So the array is terminated with null null just to show the end, and maybe you want to keep things like the help command at the end and the question mark to get a list of commands. But all these others you can pull out if you want and replace them with your own command. You just put the command and a description and name for it. In the code, you would put some text for what you want to be displayed. If someone says help and then they type in create command, for example, then it would display that little bit of help to explain how to use the command. And then you add in the processing of what you want to happen and print out when someone uses that command. And the shell takes care of the rest. It tracks how many parameters are passed through and manages all the error management if they type something wrong on the entry and that sort of thing. And a quick screenshot of one typical interface. This is from an application we developed for a customer, and it's only a subset of the command set available. But the first thing the user would do is enter in their username, enter in their password, and then all of the following commands. It's actually truncated the list here, but these are the commands available. And as I was just describing, these can all be replaced and put in with your own custom interface. And another product that comes integrated in with MQX is called wolfCrypt. That Eric mentioned in his overview. And that is actually the underlying encryption decryption engine that is used by wolfSSL and wolfSSH, but you can actually use wolfCrypt by itself and in many ways. And typically it's used to encrypt, decrypt data that is stored in Flash, or it could be used for securing entire files. And this is integrated with MQX and installed on top of any block-oriented MQX driver. And so it can be used to not only for storing information in Flash, but you can actually use it on top of any other block-based interface, such as Serial, I2C, SPI, and there's several others available as well. And the easiest way to explain kind of how this can be used is in a diagram, and there's a number of different options, and the output of the impact is a little bit subtle, but important to know. So we'll start with MQX at the bottom, and above that is one of the many block drivers available, or you have several there. And that could be used, like I said, for an external interface or for accessing Flash or some storage media like an SD card or a USB memory stick. And on top of that is the I/O subsystem. If you remember, I mentioned the I/O subsystem at the architecture diagram for all of MQX. And the advantage of the I/O subsystem is it provides a very, very consistent interface to all of the various drivers below. And it implements a POSIX-like interface. So you may be familiar with fopen, fread, fwrite, fclose type of commands. And regardless of which driver you're using and peripheral or interface you're interfacing to, you use the same sort of commands, fopen, fread, fwrite. So it makes your application code much simpler to follow, much easier to code, and then much easier to change interfaces. So if you're switching from I2C to SPI, for example, the application code hardly changes at all. You're just all using the same commands. On top of that, I have the partition driver. It's not mandatory to use a partition driver, but it is available there to you if you like. And again, the IO subsystem is here. It's not a separate instance or second instance of the IO subsystem. It's only once in your footprint, but anything above the partition driver is going to use the same fopen, fread, fwrite type of interface into the partition driver, and then it in turn is going to use fopen, read, write down into the block driver. On top of that, then you have your file system, and there's a number of options. MFS is our FAT32 file system. You can use little file system. And I mentioned exFAT is available as well. And then the corresponding driver would sit on top of that. Again, the application code is going to use the IO subsystem to go into the driver and down into the file system. And so your application code sits on top. So this is a typical architecture that is not using wolfcrypt. And now I'll show you the options available to you to where and how you can put in wolfcrypt. We'll always start with the same base components there. But in the first case, we'll put wolfcrypt right above it and the wolfcrypt driver, associated driver with it. And then more or less the same components on top of that. So in this case, I'm showing MFS as the file system. It could be anything in there, and then your application way at the top. Now, wolfcrypt will encrypt, decrypt, is used for encrypting and decrypting anything that's below it in the architecture. So in this case, all contents that are on this storage media here will be encrypted because wolfcrypt is sitting right above it. However, that may not be exactly what you're looking for. Starting with the same components and then the partition driver on top, same as what I had before, but in this case, we're going to use the partition driver to create two separate partitions, and you'll need the IO subsystem regardless of which partition you're going into. So on the left is where we'll install wolfcrypt and the wolfcrypt driver, and of course the IO subsystem, and I just picked MFS as our file system here. That's on the left side into that partition, and into the other partition, we're going to start with a file system, in this case exFAT, and its driver and IO subsystem above, and then we'll put wolfcrypt in its driver and IO subsystem, and then the application is at the top, and it can access either partition by going down either the left side or the right side to access into the partition and ultimately into the storage media. The difference here, though, is as you see the location of where wolfcrypt is. And so on the right-hand side, you can use wolfcrypt to encrypt just a single file that's on that partition, or at least individually select which files you want to encrypt or not encrypt. And so there may be something that's critical, something you want to protect, whether it's passwords or key data that you want to encrypt, but other files are less critical. And it's just a little bit faster, more convenient to not bother and send them back and forth in an unencrypted state. And then the difference to the left is that since the wolfcrypt is sitting right on top of the partition driver, everything that is on that partition will be stored in an encrypted state and will have to be decrypted when you access it from the file system, which is higher up. And so there's one last product that I'd like to talk about that is part of MQX, but also is based on wolfcrypt. And that has a very big, long, clunky looking acronym, but it stands for Password-Based Key Derivation Function 2. And this is used for securing passwords that may be stored in Flash on your device, as opposed to storing them in plain text. So, and that would prevent exposure of the passwords if your system is compromised somehow. So if someone ever was to break into a device, download the contents, what you have stored in Flash, it wouldn't be too hard to go in and find plain text passwords in there and you're pretty much handing over the keys to your system, and who knows what havoc they could wreak by doing that. So that's the purpose of using this function, and it works by combining the password and a random number, which is called the salt. And then it subsequently performs numerous iterations of a hashing function to create a key that's of a length that you define as the user. And so the passwords are stored in a hashed one-way state. You cannot decrypt it. That's the beauty of this. So even if someone had your algorithms, if they extracted the passwords, there's really nothing they can do about it. And the end result is that your embedded system would become much more resistant to typical brute force attacks to hack in, extract whatever they can, and see if they can find a backdoor or some other way in by, like the passwords, to break into your system. And just a quick screenshot to show you how this is working. It won't make a ton of sense here. It's somewhat cryptic, especially in the first 2/3 of this slide. But I really wanted to draw your attention to was this lower section. PWA stands for the password for the admin, and PWF stands for the password for factory level of access. And you can have more than two levels of access. Users may have access. It may be a maintainer that at the customer's end that has different level of access, and general users can have an access. And they can all have their own unique password. But the important thing here is when you typed in PWA, what came back was this big, huge, long string of gobbledygook here, and that is really what the encrypted version of the password looks like after it's gone through all the hashing. And that is what's stored in Flash. And when the user wants to access the system, it types in the password or what they think the password is. It goes through the same encryption technique. And then what MQX does is a binary compare of this version, which is stored, and the encrypted version of what the user entered. If it matches, they're in. If it doesn't, then you get an error message saying, sorry, password doesn't match. And so that's how you use this function. And that's about all we had time for. We wanted to leave lots of time for questions. I just wanted to wrap up with some closing remarks then. As we've seen, there's multiple components available from wolfSSL that can be utilized with MQX in many, many different ways. All of the components available from both companies are highly configurable, and they facilitate your specific requirements. As I mentioned, lots of features to turn on or off, and you can optimize for performance or footprint. And it's worth repeating again that the critical thing is to really, really nail down your requirements before you head off on a development cycle, because there's a good chance you're going to discover some things along the way, and then you have to back up and start looking at reconfiguring it. By leveraging the pre-integration that is provided with the two sets of products, you really do save a ton of development time, a ton of development money, and all the risks with implementing a secured environment for your application are mitigated to a high degree just by leveraging what's there, existing, and extremely well proven. There's no point to reinvent the wheel. You can upgrade to take advantage of new features and ciphers, which is all quite easy. So for example, a new cipher comes out in the future, you simply swap out the wolfSSL library with a new one, and away you go. You can take advantage of the latest and greatest. And in this world of a significant number of vulnerabilities and whatnot, you really need to stay on top of this. And leveraging a company like wolfSSL to stay current and keep you up to date with all the latest and best practices for security is definitely in your best interest. And regardless of requirements, it really is quite straightforward to secure your application. And certainly if you have any questions about what products you use, how to use them, what can it offer you, as said at the outset, feel free to contact us directly with any questions you have. And now we've got a few minutes that Eric and I'd be happy to answer any questions that you may have.
Thank you, Eric and Doug. So there is a question. What processor does QX run on? I think
Eric, take
MQX,
that
right?
or me?
Yeah, so I'm gonna let you grab this one, Doug. I guess they're just asking what processors MQX runs on.
Yeah.
Mhm.
Great variety. As I mentioned, we're a gold level partner with NXP, so for the most part, everything's in there. But they've got very, very extensive families in the microcontroller space. You've got MCX and Kinetis. They've got crossover and prior families as well. What they call a crossover processor family is IMX RT. Those are all ARM M7 based and run up to, I believe, a gigahertz. And then higher than that, there's a number of microprocessors, the IMX family, some Core IQ, and other larger components.
Thank you. There is another question. Does wolfSSL provide some guidance regarding public/private key management and search? Seems like this is a difficult process on embedded system with fixed firmware.
Yeah, I'll pick this one up. That's a great question. So actually we do. I mentioned in the beginning that we had a couple of other tertiary projects, things like TPM and HSM. Those are like hardware solutions for managing keys. We could also do things like remote key storage through a couple of other partner projects. Um, so yeah, it's definitely a concern and certainly something that lots of other people have thought of and put time into solving. So definitely we can help you out with those. If you want to email us with your specific requirements around that, we could have a good discussion.
Thank you. There is another question. Do we take advantage of on-chip hardware acceleration for CPUs that have this feature? And if so, can the application also access the hardware acceleration?
Oh, I would say yes, but it does depend a little bit on your environment. So when a CPU has on-chip hardware acceleration, the encryption decryption engine does take advantage of it, meaning wolfcrypt will take advantage of that on-chip acceleration. In terms of sharing it with the application, on certain types of processors, such as the i.MX family, that has multi-channel support for multiple channels to access the acceleration circuitry. So in that case, you would not need any form of mutual exclusion. It's ready to go for you. However, if you are using a CPU that does not support multiple channels to the encryption engine, you simply need to protect the circuitry with a semaphore or a mutex, and both of those are features that are built into MQX, and that can be used to prevent simultaneous access of this engine between wolfcrypt and your application.
Perfect. Thank you so much. And there's another question. Which NXP platforms are supported with wolfSSL?
Sure, I can grab that one. So I know we've done a lot of development with like the Kinetis boards. I've actually got quite a few demonstrations examples in the repository for those. But we can support any of those NXP chips natively and take advantage, like as Doug was saying, of the any hardware acceleration that might exist for those platforms.
And I would add on
Perfect.
that IMXRT family we've used extensively with Wolf products as well. And no reason why we can't use it on MCX, a newer microcontroller family.
Excellent. Yeah, thanks, Doug.
There's another question. How many tasks are involved for connection to the web server? It is one task handling everything, or do multiple tasks get created when making a connection?
The web server requires a single dedicated task. However, in addition, every new connection from a client will result in a separate dedicated task to be spawned for that connection. So in the example where I had 2 different web servers, then there really be 3 tasks dedicated to it. However, the footprint and memory requirements are pretty light. And then if you disconnect the connection, that associated task would be available for the next connection. And the advantage this way is that you can optimizes for performance. And web server performance is typically something that a user is going to notice, right? And so if it's a bit sluggish to respond, they're going to think your system's a bit slow, and so you really want a very responsive web interface. And so this seems to be the most efficient way of doing it.
Thank you. And there is another question. Can my MQX application use FIPS certified wolfSSL?
That's a great question. Yeah, so wolfSSL has gone through certification for FIPS on its cryptography module, and that module can be is software based, so we can basically use that on just about any hardware platform. So the operating environments are pretty much what we talk about in terms of FIPS. So that operating environment is a combination of your CPU and your operating system. So in this case, we'd be talking about maybe one of the NXP platforms and MQX. And so you can actually go out on our FIPS certificate on the NIST website and look at the different OE combinations that we have out there already certified. So if you're interested in getting FIPS certification for your application, you would contact us, and we're typically look at about a 3-month turnaround time for getting your operating environment on our list.
Thank you. There is another question. The wolfSSL functionality basically replaced a number of RTCS function call as mentioned earlier. So we can use the sliced SSL call for any custom network communication.
So Doug, I think there are 2 ways to approach that. So I think in most of your slides, you showed that the application would be calling into the RTCS SSL functions and then propagate down the stack, right? I guess the other way to look at that would be that you could have the application directly call a wolfSSL API, and then that you'd use the IO callbacks to call into the RTS stack. Yeah.
I would agree with that. There's pros and cons. Using RTCS allows you to upgrade a bit easier and that sort of thing. But yeah, there's no reason why you can't call wolfSSL or wolfcrypt directly.
So I hope that answered your question.
Perfect. Thank you so much. And there is a question. Are there example of using wolfSL in MQX?
Yeah, so I mentioned that we actually have a repository in the wolfSSL repository on GitHub. In the root directory, there's an MQX folder, and there's a number of great examples in there of running like the benchmark, running wolfcrypt tests. I think we have the TLS benchmarking utility in there also. So that would be a good jumping off point, a good start for your application if you wanted to check those out.
Perfect. Thank you. I think it was the last question. Thank you, Eric and Doug, for hosting an informative webinar. And thank you, everybody, for joining the webinar today. And you can keep up with our upcoming event, meet our team in person, read our blog post, and get the latest wolfSSL and embedded access updated by following us on X, connecting with us on LinkedIn, and subscribe to our YouTube channel. If you have any question, please reach out to us at fax@wolfSSL.com. And thank you again, and we look forward to seeing you on April 9th for everything you need to know about DTLS 1.3. Thank you.